kind of simple versions of multiplication. So take, for example, when you are multiplying monomials such as the below. Take 6 and multiply it by 2x. What you're going to do is you're going to multiply the numbers together times the variable, which in the end results in 12 x's. I could visually represent this by saying this. Each of these circles representing a 2x. There just so happens to be 6 of those circles, giving us 12x in total. Obviously, it's not real conducive to drawing pictures of such things, but in a nutshell, this is what example 3 introduces us to. Okay, I'm sorry, like I said, I'm going a little bit out of order, but they get a little more difficult when they look like this. Now, numerically, you can look at this and say, well, -4 times -7, you know that's a -28. But what about the x's and y's? Okay. Add them. I knew you'd remember that. When multiplying exponents, you add the exponents together. You don't multiply them. Okay, so I would break this up into -4 times +7 times x squared times x to the first times y to the fifth times y to the fourth. Remember, if there is no exponent, it's a 1. So your result is -28x cubed y9. Because of this little tidbit. Okay, because of that little tidbit. Now from there, I can kind of backtrack a little bit. I know you might think it's a little weird, but to a real simple version that illustrates this. If I give you z to the third multiplied by z to the second, since their coefficients are a 1, this little detail doesn't apply. Your end result is just going to be 1 and the sum of the exponents, z to the fifth. Or maybe a to the second times a, right? Again, there's no coefficient. So it's a 1, leaving you with 1, and this would be a to the third. Why? Because that doesn't have anything there, it's a 1. Okay? 1a to the second multiplied by 1a to the first is 1a to the third. But you don't write the 1 when that's the coefficient. Kind of going back to what example 3 showed us right here. I want to practice another simple example. Say 4n cubed multiplied by 5n squared. Because of the associative and commutative properties, we can associate and commute in multiplication to make it more convenient. I would do 4 times 5 times n cubed times n squared, 20n 5. Okay? Remember, you simply add your exponents together when you are multiplying Now we'll go to examples 4 and 5. And we're going to camp on this for just a couple seconds. Example 4. 16/5 x squared y multiplied by 15/4 x cubed y squared. Remember how we can associate and commute? Well, let's associate and commute our fractions. 16/5 and 15/4. Ignore the variables for just a brief moment. Should we cancel? Absolutely. Reduce wherever possible. Saves you some brain power. The result of the coefficients being multiplied is 12, right? 16/5 times 15/4 performed right here. Now, take your variables. x5, y3. Remember, you simply add your exponents when you are multiplying variables. Here's another one I want to do with you. Another kind of example 4. 3b squared divided by 5 multiplied by 15b cubed divided by 3. Remember, look at 3b cubed for a minute, or 3b squared. This means 3 times b to the second.
Michael and Kathleen Bedoya to the office. She'll be leaving for the day.
You can actually take this piece and break it into 3/5 multiplied by b squared over 1. And there's a reason why you might want to do that. I'll show you in a second. You can do that. And you can do the same thing with the other. 15/3 multiplied by b cubed over 1. And by the way, a lot of this, as you get familiar with it, you're not going to write nearly as much as I'm writing right now. Let's associate our numeric values together. That's 3/5 and 15/3. Because we can associate look like that. So the numeric result of 3/5 and 15/3 looks like it's 3. B squared times b third, b to the 5th. Okay? That there is an easy opportunity for a mistake. Just going to warn you right up front. Last one. What if I'm adding together some stuff being multiplied? That's going to be example 5. And example 5 there is going to apply to some stuff in the last bit, your number 32 and number 34. All right, just a couple more things I got to show you. Here's example 5, and my example 5 looks like this. The product of 2ab squared and negative 6a to the 4th b squared is going to be added to the product of a squared b and 2a cubed b cubed. All you're doing here is taking those two little multiplication problems, solving them, and then combining them if possible, if they're the same type of thing. So the first chunk, 2 times -6 is -12. A to the first and a to the fourth is a to the fifth. B squared and b squared is b to the fourth. This, when multiplied together, gives you that as a product. We're not done. We need to add that piece to the product of these two lovely things. The coefficient of a squared b is 1, isn't it? So 1 times 2, a squared a cubed, bb cubed. The product of all of this is here. Are we done? Or is there any like term collecting to be done? What's the end result? Yep. Yep. When you collect like terms and there's coefficients involved, these are the things you concern yourself with. The identity of the terms doesn't change. This is like saying I have -12 apple bananas and +2 apple bananas. I still have apple bananas after I combine them together. Okay? The variable term portion itself did not change. Just how many of them I had is what changed. Okay, here's the last thing. Turn with me, please, to page 154. And we're going to do number 35 together. Find the perimeter in the area. You guys are going to have to do 36 tonight as part of your assignment. But here's how it looks. Here's mine. This is an easy one. The perimeter is the sum of the sides. Would you agree? So what do you think the sum of all the sides is going to be? Say again? I hear 10, I hear 5. It's 10.
Wait, I thought you
Perimeter.
Perimeter?
Yeah.
Oh, I heard the other one.
That's okay. Perimeter. You're on the right track though, so that's awesome. What do you think the area is going to be? Wow, rock on. I heard it. There's area. Length times width. Associate your numbers. And you get 6, A, B, B. Otherwise known as, yes. That's it. Now the one you guys actually have to do for number 36, you're going to have to basically solve 2 separate rectangles and add together where necessary for number 36.
We got the hard one.
Hey, at least I didn't give you 37.
Or 40.